Hello students, how are you? We are discussing about the periodic table, and from last many lectures we were discussing about that as usual. What we had discussed? We had discussed about the groups, periods, elements of groups. Then we had shifted towards the physical properties, trend in physical properties, in which what we had discussed atomic radii or atomic radius. Second one was ionization enthalpy. Now the third important property is electron gain enthalpy. It is electron gain enthalpy, oftenly known as electron affinity. So electron gain enthalpy or electron affinity, the symbol is delta EGH only, where delta H is enthalpy, as you all know. Delta H is enthalpy, while EG stands for electron gain, acceptance of electron. Electron gain, it means acceptance of electron. So now we are discussing about the most important property of periodic table. Why this is most important? Because the value is inverse. It is negative value, and that's why it is important to discuss. So let us start electron gain enthalpy. What should be the definition? The definition must be like this: energy, or what we can say, heat energy released, energy released during, energy released during accepting electron by atom. Energy released during accepting electron by atom. When atom accepts electron, when any atom accepts electron, when it gains electron, it releases some amount of energy, and that energy is called electron gain enthalpy. See, we are providing electron to the atom. We are providing electron to the atom, and atom is giving energy back to us. So we had provided electron to atom, and the atom will become negatively charged, and badlama the energy gets released by the atom. So that energy is called electron gain enthalpy. Okay. Main thing that we has to focus is released energy. So enthalpy. Okay, student, remember this. This is called enthalpy. And enthalpy has two possible values. One is a negative value, one is positive value. Enthalpy has two possible values. One is negative value, one is positive value. We do not have to consider it mathematically. We do not have to consider it mathematically. Sign is indicating the reaction. Which type of reaction is there? That can be indicated by the sign of delta H. If delta H is negative, what does it mean? It means that the energy is releasing during the reaction. Energy is releasing during the reaction, and that's why what we can say, it is exothermic reaction. It is exothermic reaction. So whenever delta H is negative, don't consider it mathematically. Negative means the reaction is releasing heat, and that's why it is exothermic in nature. If delta H enthalpy value is positive, we can say the reaction is endothermic. The reaction is endothermic. It means during the reaction, the heat is absorbed. During the reaction, the heat is absorbed. So delta H has two possible values, negative and positive. Don't ever consider it mathematically. Negative value of enthalpy indicates the reaction is exothermic. Why? The positive value indicates that the reaction is endothermic in nature. Okay, now we are shifting towards our topic. So energy released during accepting electron by atom is called electron gain enthalpy. Since the energy is released, see, we already have highlighted the released word. What does it mean? Energy is releasing, and whenever energy is releasing, so can we say that the value of delta EGH, value of delta EGH will negative. So this is very difficult. This is very difficult to decide the trend. We cannot say by going up to or going top to bottom it decreases or increases. We will not use word decrease and increase in this concept. In electron gain enthalpy, we will not use increase and decrease word. Then what we can use? We can use less negative and more negative. What we can use? Less negative and more negative. Let us discuss. Okay. By moving down the group, see, by moving down the group, atomic number increases. It means number of shell also increases. Number of shell. See, watch it carefully and remember this, understand this. So atomic number increases, number of shell increases. It means what? Distance of electron from nucleus increases. So attraction of electron towards the nucleus decreases, and this attraction is called electron gain enthalpy. This attraction, when the electron attracted towards the atom, it releases some energy. This energy is called electron gain enthalpy. So by moving down the group, attraction towards the electron decreases, and since attraction towards the electron decreases, when we provide electron to the atom, it will release less energy. Let's make it simple. Suppose we have two elements, X element and Y. X is at the top, Y is at the bottom. We have two elements in which X is at the top, Y is at the bottom. Okay, X is small in size, so its electron will be nearer to nucleus. Y is large in size, so its electron will be away from nucleus. Now this element is small in size, it requires more electrons. Small sized elements or atoms always requires more electrons. So this element will require more electrons, while this one will require less electrons. So which element has highest affinity, highest attraction towards the electron? This element. So when we provide electron to this element, it will provide us a good amount of energy because it already has requirement of electron, while this element has no requirement of electron. So when we provide electron to this element, what will happen? It will release less energy. Okay. So this element is releasing more energy. What does it mean? This element is releasing more energy. What does it mean? The value of electron gain enthalpy for this element is more negative, releasing exothermic. So value is more negative for this element, while this element is releasing less energy because it does not require electron anymore. So this electron will release less energy, and that's why the value of electron gain enthalpy is less negative. So at the top, the value of EGH is more negative. At the bottom, it is less negative. So can we say by moving down the group, it is becoming from more negative to less negative. So what we can write? We can write the value of delta EGH becomes less negative. We will not write increase or decrease. Increases or decreases we will not write. We will write less negative or more negative. So can we say delta EGH becomes less negative? Note it down, then we will discuss about the period. Okay, now shifting towards the period. Let it be over there. Okay, we are shifting towards left to right. We are shifting towards left to right. So when we are shifting towards left to right, what will happen? Atomic number decreases. Number of shell does not increase. It remains as it is, as you all know. So can we say distance of electron from nucleus decreases? So can we say attraction of electron towards nucleus will increase? Now attraction of electron towards nucleus will increase. It means what? That element requires more amount of electron. That element has more affinity towards electron, and that is called electron gain enthalpy. So can we say delta EGH becomes more negative? This is very conceptual, very important portion. Okay, so if you are not able to understand in first time, rewind video and again watch this. Okay, note this down. Now, what are the exceptions? Are there any exceptions? Yes. Let us decide or discuss about the exceptions. Exceptions. There are two exceptions between oxygen and sulfur, fluorine and chlorine. These are the members of same group. These are also the member of same group. As we had discussed over here, that by moving down the group, by moving down the group, the value of delta EGH, the value of delta EGH becomes less negative. So when we write in sentence form, delta EGH of oxygen should be more negative than value of delta EGH of sulfur. This should be the ideal condition. This should be the ideal condition. But the exception is there. What is exception? Exception is that the value is inverse. Value of delta EGH of sulfur is more negative. Is more negative than value of delta EGH of oxygen. The actual exception is this. Same exception can be written in fluorine and chlorine. Instead of fluorine, oxygen, sulfur, you can write fluorine, chlorine. Okay, this is exception. And what is the reason behind exception? Let us discuss the reason. So as you all know, the oxygen electronic configuration is 1s2, 2s2, 2p4, while for the sulfur it is 1s2, 2s2, 2p6, 3s2, 3p4. Okay, understand this carefully. Oxygen has 2p orbital as outermost orbital. 2p orbital as outermost orbital, while the sulfur has 3p orbital as outermost orbital. Okay, the size of 2p, is smaller than 3p. The size of 2p is smaller than the size of 3p. It means 2p is small in size. It is already small size. It means the electrons are nearer to each other. They are close to each other. They already have 4 electrons and the size is small. It means electrons are close to each other. Since the electrons are close to each other, they will repel each other. They will repel each other. Now we are adding another one electron. Electron gain enthalpy, it means addition of an electron. We are adding another electron. What will happen? The distance between electron will decrease, and due to singular charge they will repel each other. So repulsion is more in small orbital, while repulsion is less in large orbital. So which one is small orbital? 2p. It is for oxygen. So when we add electron to the oxygen, the repulsion between electron will be maximum compared to sulfur, and that's why the released energy will be less in oxygen compared to sulfur. Same scenario we can assume about the fluorine and chlorine. Just notice down